Good afternoon, everybody, and welcome back to another glorious day. Today, we are going to be continuing on our journey with coordinate planes, but now we're going to start integrating some other concepts that you've already seen before. And one of them that you probably notice off the bat is this input-output table. Now, in order for you to follow along with this more effectively, if you go to Mentoring Minds, page 290, there are two problems on this page. We are going to look at both of these together, so feel free to use your Mentoring Minds book to take notes. That way you can follow along with me as I work. So, if we're looking at page 290, at the very top problem, it gives you a coordinate plane. And again, this is quadrant 1. We're only looking at quadrant 1 in 5th grade. You'll learn that later on, there are actually 4 quadrant planes. If you continue our vertical line and our horizontal line, there's actually a second quadrant, a third quadrant, and a fourth quadrant. The biggest thing that you need to remember is that where all 4 quadrant planes intersect is going to be at this 0 point right here. So where the quadrants intersect at ordered pair 0, 0. Okay. Now, also on this page with this first problem, you'll notice that they've already got some information in our input-output table and on quadrant 1. But I want to walk you through this problem and the one below it on that same page. That way you can understand how they're coming up with this. Now, if you look on that page, it says how to graph a pattern from an input-output table. And it says the table and graph represent the rule of add 2. So they tell us that when x is 2, y is 4. That when x is 5, y is 7. When x is 7, y is 9. Now I'm skipping 6 because I added 6. We'll take a look at that here in a minute. And when x is 8, y is 10. And they've told us the rule, but we can look at this and go, okay, well, to turn 2 into 4, I can either add 2 or multiply by 2. In order to turn 5 into 7, the only thing I can do is add 2. 7 plus 2 is 9. 8 plus 2 is 10. So the rule for this input-output table is to add 2. And I'm going to go ahead and fill in that process for all of my rows. So this means we now know that 6 plus 2 is 8. And when we look down at the equation down here, there's an equation that's actually happening here. And our final product, our sum, our difference, our product is our y. So it's telling us that y, whatever the value of y is just a placeholder, equals x plus 2. So if we made x 11, 11 plus 2 would equal 13. Essentially, this is simply the equation for the input-output table that they've given us. So now let's take a look at graphing these ordered pairs. Well, first we need to make sure we know what the ordered pairs are. I'm going to start with my x's. So 2, 5, 7, 6, and 8. Now, our ordered pairs are always going to be x, comma, y. So if we know what our x's are and we've already filled that in, now we need to just fill in our y correspondence with each x. So 4, 7, 9, 8, and 10. And the reason I put this 6 out of order is I wanted you to make the connection that it doesn't matter which order our x's are in, the process is still going to be the same. So therefore the ordered pairs with our x's is going to be the same no matter where they are in the rows. That doesn't matter. So let's start with our first ordered pair of 2, 4. So when you're putting things on a coordinate plane, when you're graphing them, you need to start at the intersection of where your quadrants all 4 intersect. And remember, all 4 quadrants intersect at 0, 0, which is this point right here. So I'm going to start at 0, and I need to go horizontally until I find 2. So I'm going to continue going down horizontally along my x-axis. So this is just your reminder that this is your x-axis and this is your y-axis. So I'm going to follow my x-axis until I get to 2. And then I need to go up vertically up my y-axis until I find 4. And then I find where the 2 and the 4 intersect. So this is ordered pair 2, 4. Vertically or horizontally to 2, vertically to 4, that's where they intersect. Now let's look at our next ordered pair. I'm going to start at the intersection of the quadrants at 0, 0. I need to go horizontally until I find 5, and I'm going to go vertically up the y-axis until I find 7. And then I'm going to find where my 5 and my 7 intersect, and that is my ordered pair 5, 7. Now we need to look at 7, 9. So I'm going to start at where my quadrants intersect, slide all the way over to 7 horizontally, and then I'm going to go vertically until I find where the 9 on my y-axis intersects with the 7 on my x-axis. So we have 7, 9. Now to graph my next ordered pair, which is 6, 8. Start at where the quadrants intersect at 0, 0. Go horizontally until I find the 6 on my x-axis. Go vertically until I find the 8 on my y-axis, and then find where the 2 intersect. So if I go down, I can find the 6 on my x-axis, go this way to find the 8 on my y-axis for 6, 8. And now I need to look for 8, 10. Starting at 0, 0, I'm going to go horizontally all the way out to 8, and then go vertically on my y-axis until I find 10, and find where those two intersect, and this will be 8, 10. Now let's take a look at what happens when we add some other numbers in here. What happens if we have 0 as our x, 1 as our x, 3 or 4? Well, we know the process is going to stay adding 2 every time. So in this case, 0 plus 2 is 2, 1 plus 2 is 3, 3 plus 2 is 5, 4 plus 2 is 6. So our ordered pairs are going to be 0, 2, 1, 3, 3, 5, and 4, 6. And remember this equation. We were looking to solve for y. We had to take our x and add 2 to equal y. And we could even write it up here. X plus 2 equals y. And that even lines up with our input-output table. So find our 0. Our x is actually 0, which is fine. So we're going to stay at 0, and we're going to go vertically until we get to 2, until we find 0, 2. For this next ordered pair, we go horizontally to 1, and then we need to go up until we find 3 along the y-axis. 1, 3. Now we're going to find horizontally starting at 0, go along the x-axis until we find 3, and then we're going to go vertically along the y-axis until we find 5, and we need to find where 3 and 5 intersect. And last but certainly not least, we have 4, 6. Start at 0, go horizontally until we get to 4, then go vertically until you get to 6, and find where the 2 intersect for 4, 6. Now, if you notice, this creates a very nice line, okay? And when you actually start working in middle school with graphing calculators and graphing lines and graphing equations on coordinate planes, you'll be able to look back and go, "Oh, I've seen this before. That makes sense." All right, so this was the first problem on that page. I want us to take a look at the second problem down below. Now this one, again, we're just looking at whole numbers. This one tells us that our x points are 0, 1, 3, and 5. I'm adding 2 and 4. Again, it does not matter what order our x's are in. The process is not going to change, and therefore, no matter what order there are in the rows, our y is still going to be accurate. Now, thankfully, they tell us what they're doing with this one, because they're telling us that the equation is x times 2 equals y. Now, there's a couple of different ways that you can write this, and the one most common, we're actually going to write down here next to our equation. Y equals 2x. Okay. It may also be written as y equals 2 dot x. That dot can mean multiplication. And again, we wrote it up here, x times 2. That's the exact same thing. It could also be written as y equals parentheses 2 times x. All means the same thing. Our process is simply going to be to multiply times 2. Zero times 2 is 0. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. 2 times 2 is 4. 4 times 2 is 8. So our ordered pairs going x comma y is going to be, I'm going to go ahead and put my parentheses in here just to make this a little quicker on myself. 0, 0, 1, 2, 3, 6, 5, 10, 2, 4, 4, 8. All right, so now let's get to graphing these on our first quadrant. Now remember, this point here where the 0 is where all 4 quadrants intersect, is at 0, 0. Now the nice thing is our first point is actually relatively easy, because this corner right here is 0 horizontally and 0 vertically. So we already have our 0, 0. It's right there in that corner. It's where all 4 quadrants intersect. Our first point is 1, 2. So I go horizontally to 1, vertically until I find 2. 3, 6, horizontally to 3, vertically until I find where it intersects with 6. 3, 6. I'm sorry. We already cut 1, 2, 3, 6, 5, 10. So I'm going to come to 5, and then I'm going to go vertically all the way until I get to 10. Our next point is 2, 4. Horizontally to 2, vertically to 4. and then 4 comma 8, horizontally to 4, vertically up until we intersect with 8. Now, another thing you need to remember is that you can describe how to find these points with words, not just with numbers. So let's say that I have a compass rose. You know these from social studies, from maps. North, south, east, and west. Never eat soggy waffles. That's my saying. We are going to describe how to get from one point to the next using a sentence with compass rose navigation. So the first thing we need to do is we're going to start at our 0, 0, and you always want to list how to get horizontally and then vertically with movement. So if you're talking movement, you're going to describe the horizontal move first, then vertical second. All right, so if I'm starting at 0, 0, I can describe this as we are going to move east 1 square and go north 2 squares. So we can say move east 1 square, then north 2 squares. So that's one way we could describe this. We could also say, using left and right, we could also say move 1 square to the right and then 2 up. Move 2 squares to the right. I'm sorry, that's move 1 square to the right. I apologize. Move 1 square to the right. We're going 1 to the right and 2 north, or 2 up. 2 squares up. Okay. Be aware that cardinal directions, especially if they give you questions dealing with maps, are very likely going to ask you how to get to another point based on a given written direction. Okay. All right, well, thank you guys for joining me. I hope that this has helped. I hope that between these two problems, you understand the connection between our quadrant and our input-output boxes, and how you can turn the process of an input-output box not only into the equations, but also to the ordered pairs. All right, if you have any questions, please let me know, and we'll see you guys next time.